Dear Seeker, as we reach the end of this exploration into artificial intelligence and hardware, it is worth pausing, not to conclude, but to reflect. We have seen how intelligence is no longer confined to abstract code. It is etched into silicon, embedded in devices, and expressed through machines that sense, move, and act in the physical world. Chips accelerate thought. Devices bring intelligence closer to daily life. Robots extend human reach into environments once beyond our limits. And yet, through all of this progress, one truth remains steady. Technology does not define purpose. Humans do. AI-powered hardware does not wake with intention, nor does it wonder about consequence. It executes what it is designed to do, with remarkable efficiency. But efficiency alone does not create meaning, nor does capability guarantee wisdom. This is where human responsibility becomes essential. Every design choice reflects a value. Every deployment shapes behavior. And every intelligent machine, no matter how advanced, carries the priorities of its creators into the world. As seekers, our task is not to resist progress, nor to surrender to it blindly. It is to remain attentive, to ask careful questions, to value safety alongside innovation, and to ensure that intelligence serves life rather than overwhelms it. The future of AI and hardware will be built quietly. Not in one dramatic moment, but through countless small decisions made by engineers, policymakers, organizations, and individuals. And in those decisions, humanity reveals itself. Thank you for choosing to engage with this topic thoughtfully, rather than reactively. Understanding is the first step towards stewardship. If this reflection helped bring clarity, I invite you to continue exploring, with curiosity, patience, and care. Because when intelligence touches the world, it is wisdom that must guide its hands. Stay thoughtful. Stay grounded. And above all, stay human. When intelligence enters the physical world. Dear Seeker, for a long time, artificial intelligence lived in an invisible realm. It existed behind screens, inside data centers, software applications, and digital conversations. It analyzed, predicted, and generated, yet remained distant from the physical world we inhabit. Powerful, yes, but abstract. Today, that boundary is dissolving. Intelligence is no longer confined to code alone. It is being etched into silicon, embedded into devices, and woven into machines that can sense, move, and act. AI is entering the world of hardware. Chips that think faster, devices that learn locally, and robots that interact with their surroundings. This shift marks a quiet but profound turning point. When intelligence moves into hardware, decisions are no longer theoretical. They influence physical systems, factory floors, hospital rooms, roads, homes, and cities. A calculation becomes a movement. A prediction becomes an action. An action, unlike software output, carries consequence. This is why AI combined with hardware deserves careful attention. Not every advance is visible in headlines. Some of the most important changes happen silently, inside processors, sensors, and machines that work continuously in the background. These systems promise efficiency, precision, and scale. But they also raise deeper questions about control, safety, responsibility, and trust. As seekers, our role is not to react with fear or blind excitement. It is to understand what is unfolding beneath the surface. In this video, we will explore how artificial intelligence and hardware come together, why specialized chips matter, how intelligent devices are changing daily life, and what it means when machines gain the ability to act in the physical world. We will move slowly, thoughtfully, and without hype. Because when intelligence touches reality, understanding becomes not just useful, but necessary. Let us begin this journey together. Why artificial intelligence needs hardware. Before artificial intelligence can reason, learn, or act, it must first exist in a physical form. At its core, AI is not an abstract force, it is computation. And computation requires hardware, chips that process signals, memory that stores patterns, sensors that gather data, and energy that sustains it all. No matter how advanced an algorithm may be, it cannot function without a physical foundation. For many years, general-purpose computers were sufficient. But as AI models grew larger and more complex, their demands began to exceed what traditional hardware could efficiently provide. This marked a turning point. In the chip war, we learned that modern intelligence, artificial or human, is inseparable from silicon. The ability to design and manufacture advanced chips now determines who can build the most capable AI systems. Software defines logic. Hardware defines limits. The speed of learning, the cost of training, the energy consumed, and even who has access to AI, all of these are shaped by hardware choices. A powerful algorithm running on weak hardware remains constrained. Conversely, advanced hardware can unlock entirely new possibilities for intelligence. This is why AI progress today is no longer driven by software alone. It is driven by the coevolution of algorithms and machines. Chips are becoming more specialized. Memory is being redesigned to reduce bottlenecks. Entire architectures are now optimized specifically for learning and inference rather than general computation. As seekers, it is important to recognize this truth. The future of AI is not floating in the cloud, it is built, layer by layer, in physical systems. Understanding AI, therefore, requires understanding hardware. Because intelligence, no matter how digital it seems, always rests on something tangible. And that tangible foundation is where the real limits and responsibilities begin. AI chips, the new brains of the machine age. Once the importance of hardware is understood, a deeper question arises. What kind of hardware does artificial intelligence actually need? For decades, traditional processors were designed to handle many different tasks reasonably well. They were flexible, reliable, and general. But artificial intelligence asks for something different. It does not think sequentially, it thinks in parallel. It processes vast numbers of simple calculations at the same time, learning patterns rather than following fixed instructions. This demand has given rise to a new class of hardware, AI-specific chips. Graphics processing units, tensor processors, and neural accelerators are built to perform massive parallel operations efficiently. They trade general flexibility for speed, scale, and energy efficiency, qualities essential for training and running modern AI models. In Architects of Intelligence, many leading researchers emphasize that breakthroughs in AI are increasingly limited not by ideas, but by compute. In other words, what we can imagine often exceeds what current hardware can support. Smarter models require smarter silicon. This shift has transformed chips into strategic assets. Performance determines who can train large models. Energy efficiency determines whether AI can be deployed widely. Cost determines who gains access, and who is left behind. AI chips are no longer just components. They are enablers of capability. Yet, even these powerful processors remain tools. They do not understand meaning or intention. They execute mathematical operations at extraordinary speed, but they depend entirely on human goals. As seekers, this distinction is grounding. Intelligence may accelerate, but it does so within boundaries shaped by physics, energy, and design choices. The future of AI will not be decided by algorithms alone. It will be shaped by the quiet evolution of chips, engineered brains that determine how far intelligence can reach, and at what cost. And with that reach comes responsibility, one etched directly into silicon. Edge devices, intelligence moves closer to reality. Dear seeker, as artificial intelligence grows more capable, another quiet transformation is taking place. Intelligence is moving closer to where life actually happens. For many years, AI lived primarily in large data centers. Information was collected from devices, sent to distant servers, processed, and returned as results. This model enabled rapid progress, but it also introduced delays, privacy concerns, and heavy energy demands. Today, a different approach is emerging. AI is increasingly being embedded directly into edge devices, smartphones, cameras, wearables, medical instruments, vehicles, and household systems. These devices can sense their environment and process information locally, without relying entirely on the cloud. This shift matters more than it may appear. When intelligence operates at the edge, responses become faster. Systems can act in real time. Sensitive data can remain on device, improving privacy. And energy usage can be reduced by limiting constant communication with centralized servers. In You Look Like a Thing and I Love You, we are reminded that AI systems behave best when they are tightly constrained and placed in clear contexts. EdgeAI naturally imposes such boundaries. It limits scope, focuses purpose, and grounds intelligence in physical reality. An edge device does not attempt to know everything. It knows what it needs to know, here and now. This design philosophy brings balance. Intelligence becomes more practical, more accountable, and more aligned with real-world conditions. For seekers, this transition invites a deeper appreciation of restraint in technology. Not every problem requires infinite data or global reach. Sometimes, intelligence works best when it is local, limited, and purposeful. EdgeAI represents a quiet maturity in design, a recognition that intelligence does not always need to be centralized to be powerful. Sometimes, wisdom lies in bringing thinking closer to action. Robotics, when intelligence gains a body. When artificial intelligence enters robotics, something fundamentally changes. Until now, intelligence could observe, predict, and advise. But in robots, intelligence acts. It moves through space, manipulates objects, and interacts with environments that are unpredictable, physical, and often fragile. This is what makes robotics such a profound step. A robot is not just software or hardware alone, it is a fusion of perception, decision-making, and motion. Sensors gather information. AI models interpret that information. Actuators then turn decisions into movement. Each step must function in harmony, and failure at any point can have real-world consequences. In Life 3.0, this transition, from intelligence in software to intelligence with physical embodiment, is described as a major evolutionary leap. Once intelligence can act in the world, questions of safety, responsibility, and trust become unavoidable. A software error may crash a program. A robotic error can damage property, or cause harm. This is why robotics demands a higher standard of care. Machines must be trained not only to be capable, but to be cautious. They must navigate uncertainty, adapt to unexpected conditions, and operate alongside humans who are neither predictable nor perfectly rational. Robotic intelligence is also humbling. The physical world is messy. Objects slip. Sensors fail. Environments change. What seems simple to a human, picking up a cup, opening a door, can be extraordinarily difficult for a machine. And yet, progress continues. Robots are assisting in warehouses, hospitals, agriculture, and exploration. They extend human reach into places that are dangerous, distant, or exhausting. For seekers, robotics offers a clear reminder: intelligence alone is not enough. When machines act in the world, restraint becomes as important as capability. Because embodied intelligence does not just think, it touches reality. And reality demands responsibility, ethics, safety, and the question of control. As artificial intelligence becomes embedded in chips, devices, and machines that act in the physical world, a crucial question emerges. Who is truly in control? When intelligence remains purely digital, errors can often be reversed or contained. But when AI operates through hardware, driving vehicles, managing infrastructure, assisting in healthcare, or guiding robots, mistakes carry tangible consequences. This makes ethics and safety central, not optional. AI-powered hardware systems make decisions at speeds and scales beyond human reaction time. While this can increase efficiency and precision, it also demands carefully designed safeguards. Autonomy must be balanced with oversight. Capability must be matched with restraint. In human compatible, a central insight is emphasized. Intelligent systems must remain aligned with human intentions, even as they grow more capable. When machines optimize goals without understanding values, unintended harm can emerge quietly. Hardware makes intelligence real. Reality demands accountability. Who is responsible when an autonomous system fails? The designer, the manufacturer, the operator, or the algorithm itself? These questions do not have simple answers, but they cannot be ignored. Ethics in AI hardware is not only about preventing catastrophic failure. It is also about everyday choices, fairness in deployment, transparency in decision-making, and respect for human autonomy. For seekers, this moment calls for humility. No system is perfect. Complexity increases risk. And confidence without caution can be dangerous. Safety is not an obstacle to progress. It is what makes progress sustainable. As AI-powered machines become more present in daily life, the true measure of advancement will not be how independent they become, but how responsibly they are guided. Because the most powerful intelligence is not the one that acts fastest, but the one that knows when not to act. The future, cooperative intelligence. As we look toward the horizon of artificial intelligence and hardware, it becomes clear that the future is not a question of domination, but of collaboration. Machines are becoming faster, more precise, and more capable of acting in the physical world. Chips grow more specialized. Devices grow more intelligent. Robots grow more adaptable. And yet, none of these systems possess purpose of their own. Purpose remains human. In the fourth industrial revolution, the emphasis is placed not on technology replacing humanity, but on societies learning how to integrate intelligent tools wisely. Progress is not measured by automation alone, but by how well humans and machines complement one another. AI-powered hardware excels at endurance, precision, and scale. Humans excel at judgment, creativity, empathy, and moral reasoning. The most powerful systems of the future will combine these strengths. Surgeons assisted by intelligent instruments. Engineers supported by adaptive machines. Workers collaborating with robots that handle the heavy, repetitive, or dangerous tasks. This future requires intention. If autonomy is pursued without boundaries, trust erodes. If efficiency is prioritized without dignity, resistance grows. But when intelligence is guided by values, technology becomes an extension of human capability rather than a replacement. For seekers, this vision offers reassurance. The story of AI and hardware is not about losing control, it is about learning how to guide power responsibly. The future will not belong to the smartest machines. It will belong to the wisest partnerships. And wisdom, by its nature, cannot be automated. It must be cultivated. Dear Seeker, as we reach the end of this exploration into artificial intelligence and hardware, it is worth pausing, not to conclude, but to reflect. We have seen how intelligence is no longer confined to abstract code. It is etched into silicon, embedded in devices, and expressed through machines that sense, move, and act in the physical world. Chips accelerate thought. Devices bring intelligence closer to daily life. Robots extend human reach into environments once beyond our limits. And yet, through all of this progress, one truth remains steady.